Hi champs, welcome to the last section of this chapter. It's about the exercises and let us go ahead and discuss about the exercises that are given at the end of the chapter. So the first question, which of the statement about the reaction below are incorrect? Lead oxide plus carbon gives lead plus carbon dioxide. Okay, lead is getting reduced. No, it's the lead oxide that gets reduced. So this is incorrect. A is incorrect. Carbon dioxide is getting oxidized. No, it is the carbon that gets oxidized. So statement B is incorrect. Carbon is getting oxidized. Yeah, that's right. And lead oxide is getting reduced. That's correct. So what are we requested to give here? The reaction below are incorrect. Okay. What is incorrect? A and B are incorrect. So the answer is 1. Okay. That's because the lead oxide getting reduced and carbon is getting oxidized. Hence A and B are incorrect. So the answer is 1. Let's go to the next. So Fe2O3 plus 2Al gives Al2O3 plus Fe. The above reaction is an example of a replacement of iron. Aluminium displaces iron. So this is an example of displacement reaction. So the answer is D. Okay. So aluminium is more reactive than iron and it displaces iron. What happens when dilute hydrochloric acid is added to iron fillings? HCl plus iron gives FeCl2 plus H2. So the option is hydrogen gas and hydrogen iron chloride are produced. Answer is A. That's right, and this is the reaction. So it's self-explanatory. And what is a balanced chemical equation? Why should chemical equations be balanced? So we already know the answer for this because it has to be balanced because there is a law of conservation of mass and any chemical reaction need to conform to this law, and hence the reaction need to be balanced. So so all these examples what is given here, we have already discussed those in the previous videos, so you can just read through that and you will easily understand what it means. Translate the following statements into chemical equations. It is self-explanatory and you can understand all these questions and the answers. So question number 6, balance the following chemical equations. Okay, I've given the answers again here, so you can make an attempt. As I told you, if you have the rough note with you, you can just write these equations, try to balance them, and if you are not able to balance them, then you can have a look at the answers and try to understand them. But if you apply your logic, I think you can go ahead and get them balanced very easily. The tip is try to balance the one that has the maximum difference. Try from that particular element or from that group. So again, write the balanced equations, chemical equations for the following reactions. Okay. Again, the answer is given. It is self-explanatory. And 8th question, write the balanced chemical equation for the following and identify the type of reaction. Now, good. So AB plus CD gives AD plus CD. That is double decomposition. Then zinc carbonate gives zinc oxide and carbon dioxide as decomposition. We discussed about this with calcium carbonate, limestone. Calcium carbonate on heating gives calcium oxide and carbon dioxide. So there, here we have zinc. Hydrogen plus chlorine gives hydrochloric acid, HCl. That is combination. Two simpler compounds combining together one. And magnesium plus HCl gives MgCl2 and H2. This is displacement again. Yeah. What does one mean by exothermic and endothermic? Exothermic is when the heat is released, and endothermic reaction is one where the heat is absorbed and we feel cool. We feel cold. And the decomposition of vegetable matter into compost is also an example of exothermic reaction. Okay, the term exo means outside, so all these we have already discussed in our previous videos. So you can just go ahead and read them just to understand what is given, because it is repeated. And here I have tried to give you some reactions where the amount of heat absorbed or the amount of heat released is also mentioned. Okay, so these are endothermic reactions. So the amount of heat absorbed is given there for the two reactions. And why is respiration considered an exothermic reaction? So the carbohydrate we consume as food is converted into glucose and stored in our cells. During respiration, the glucose reacts with the oxygen that we inhale to form carbon dioxide, water, and energy. Since energy is released in the form of heat. Now, we are warm-blooded. We have some heat energy within us, correct? So it's a sign of being alive. So that is the energy within us, and when that energy is released, it is released in the form of heat energy. So after respiration, we get energy in the form of heat. So that is an exothermic reaction. So why are decomposition reactions called the opposite of combination? It's very simple. Combination, two simpler or two or more reactants combine to form one, and in decomposition is exactly opposite. One reactant on heating or due to sunlight or due to electrolysis, they decompose. They decompose into two or more products. Okay, so here's an example we already discussed, and the reaction in which single product is formed from two or more reactants is known as a combination reaction. So we have the reaction again mentioned there. Write one equation for decomposition reaction where energy is supplied in the form of heat, light, or electricity. Now, we have already discussed about these reactions, but the first one is an example of thermal decomposition, that is copper carbonate on heating gives copper oxide and carbon dioxide. Electrolytic decomposition, electrolysis of water. So water, when it is electrolyzed, we get hydrogen and oxygen. Photodecomposition is silver chloride on sunlight. It gives silver and chlorine. What is the difference between displacement and double displacement? Displacement is when when an element of higher reactivity displaces an element of lower reactivity from its compound. That is what is displacement all about. And double displacement is when the ions exchange and they form new compounds, new products. Okay, so electrolytic decomposition, photodecomposition, no. Sorry, I'm sorry, I went to the previous slide. So AgNO3, and what is this? In the refining of silver, what happens is, this is interesting, because if you remember the elements with low reactivity, there you find that copper is more reactive than silver. So in silver nitrate, copper replaces silver. So we get copper nitrate, and we get silver gets displaced. Okay, so that is a reaction where it is used in extraction of silver. So what is a precipitation reaction again? Two compounds in aqueous form, they react with each other, and one insoluble salt is formed. That's what is precipitation reaction. So we have the example for that. And the precipitate formed is silver chloride, which is insoluble in water, but sodium nitrate is soluble in water. Okay, so explain the following in terms of gain or loss of oxygen. Okay, self-explanatory, and here we find copper plus oxygen gives copper oxide, magnesium plus oxygen gives magnesium oxide. Both these are examples of oxidation. Zinc oxide plus carbon gives zinc and carbon dioxide, carbon monoxide, I'm sorry. So that is a reduction of zinc oxide and oxidation of carbon. Copper oxide plus hydrogen gives copper plus water. Now that again is reduction of copper oxide, and hydrogen is oxidized because it gains oxygen. Oxygen is reduced because that gains hydrogen. So you can just go through that. Again, it's self-explanatory. And a shiny brown colored element heating in air becomes black in color. We discussed about this. It's copper oxide, and when hydrogen is passed over heated copper oxide, we get the copper back because hydrogen reacts with the oxygen, and it exposes the copper. Why do we apply paint on iron articles? Because iron can rust and it can corrode, and that permanently damages the iron articles. Paint is inert, it doesn't react with the oxygen. So when we paint the iron articles with, when we paint the iron articles, the paint protects the iron articles from getting corroded, from rusting. That's why we paint. So oil and fat containing food items are flushed with nitrogen. Why? Because nitrogen is inert, it doesn't react with the fat and the oil that is present in the deep fried food. So oxidation doesn't happen and the food remains consumable for a long period of time. That's why we put nitrogen in all the packed fried food items. So we already know what corrosion is and we already know what rancidity is. So it's a repeat question. So these are the questions that are given in the last part of the lesson and we have discussed them. So chapter 1 is over and let us meet in chapter 2. Thank you.